John, since we've got you there and your time is so precious and valuable and you have to leave at a few minutes before the hour, I just wonder if you'd like to start, and we'll just wait for Gers to come on in.
Do we have video?
Yes.
All right.
Yes, you're on video. There you are.
Okay, so great. Welcome, everyone. Thanks for giving me a chance to talk. My schedule hasn't allowed me to join very much, but I've got a report from Jim Green to my right, then Mike Wargo to my left, that it's been going exceedingly well. And I think all of you know that I'm a huge fan of having virtual forums for a variety of reasons, one of which is I think all of you can appreciate the fiscal difficulty we're in and the various restrictions on travel. And rather than throwing up our hands and saying, okay, well, we just won't do science anymore, I think that all of you have responded exceedingly well to the environment we're in, to say, okay, well, we're not going to give up on science, so how can we have meetings? How can we interact? And as well, it's saving a lot of jet fuel, which is, flying around the country, generating greenhouse gases. So, all right, I've tap danced long enough. Mr. Bill Gerstenmaier is here as well, and we're just thrilled, that all of you are so interested in the Lunar Science Virtual Forum, in the new survey construct. We're very excited about it because it is, about a much larger team of people, and constituents in exploration, and we think the Lunar Science Forum has been Institute has been so successful that we're looking forward to the expansion of that going into the future. As you know, we've been talking about not just lunar science and Mars science and humans beyond low Earth orbit, but specifically, going out and interacting with a near Earth asteroid, maybe even a potentially hazardous asteroid, and that's garnered a lot of attention, and I'm sure it's something that all of you have been paying attention to, something we've been talking a lot about up here. So thanks. We're looking forward to your questions, and I'll hand it over to Bill Gerstenmaier for any comments.
Yeah, I don't have a whole lot of comments up front. I think, roughly about a year ago, John and I got to talk to you in this same kind of format, and it's encouraging to see what you've done in the past year and to see some of your reports and some of the links that you guys have been sending me that I've been looking at and reviewing, and the quality of some of the papers and the documentation has been just really first-rate and outstanding. So it's exciting for me to get to see kind of us go from a concept to actually start delivering some stuff that we can take a look at and see some products. So that's really encouraging. I think it's also good that we're all back together again a year later just to kind of tag up and see where how we're moving forward and how we can do things better. I walked in and John was talking about the new world of doing everything virtually, and there's some advantages to that. There's also some disadvantages. But
actually, Gersten, it looks like we're in the same room, but we're not even in the same room. You wouldn't know it.
That's the next generation of virtual reality, right? But we'll see. But anyway, I guess I just look forward to your questions, and we're both here to answer any questions or comments that you have.
Great. Well, thank you guys for the comments. And while we're waiting for people to type in their questions, I think you would probably both really appreciate what we did for the Shoemaker Award this year. We handed off the medal, and we actually used a teleportation device where I handed it off to the side, and our recipient, Dr. Bill Hartman, picked it up from the other side, and he put it over his head. It was really kind of cute. So,
would you have any use for that kind of technology?
We're looking at 3D printing, so the next time you can just send it to his printer next to him, and it'll print the metal out next to him. He can pick it off of the printer. So.
That sounds great. That sounds great. Well, I'm sure that one of the questions that folks have is just they would probably like to hear from you both a year later where we are in terms of our science and exploration directions, what you see happening, what's on the front burner.
Well, I think since we last spoke, we've had our Mars program planning group come to a close. We initiated a science definition team for the Mars 2020 program, and if we look back about 16 months, it looked like our Beyond Low Earth Orbit science program to Mars anyway was going nowhere. To be blunt, I mean, we still hadn't landed Curiosity on Mars yet, and I think that's been great science. But in the meantime, we've actually got quite an amazing program. Of course, it leads off with Curiosity heading to Mount Sharp. In November, we're going to launch the MAVEN instrument to understand the upper atmosphere of Mars. Then in 2016, we'll launch the InSight mission, and the European Space Agency will launch their Trace Gas Orbiter mission, of which we're a partner. In 2018, the European Space Agency, along with Russia in both of these missions and U.S. participation, will have the ExoMars rover. And the new exciting development was the Mars 2020 rover, which we've just concluded an instrument definition team. And the reason I'm stressing this Mars stuff is that it's not just a science mission, it's a science, human exploration, and operations mission, and a space technology mission. This is going to have a much higher level of integration of those directorates than we had on the Curiosity rover, which already had quite a bit of participation. And so in the science realm, we'll have a new suite of instruments, we'll have new sample handling, and from the human exploration side, we'll have some kind of in-space resource utilization experiment, and then some new technology to wrap all of it up.
Yeah, again, I think the Curiosity stuff has been really good for us. We got the entry data, which is tremendously important, looking at the entry data and seeing how that works. And then the radiation data that we're getting we got in transit is really important to us. That's been handed off to our medical folks to go start taking a look at. And then the actual radiation data from the surface of Mars is also very intriguing. You can see the 3% change in radiation depending on whether the sun's out or the sun's not out. I mean, that's surprising to me, to think that thin an atmosphere can actually have those kind of effects just based on how much it expands through the solar heating. So that's intriguing data, and I think there's some papers that just got published in that area that are pretty compelling. As John described, as we look to the new Mars mission, we're thinking about some kind of in situ or in space resource utilization activity, maybe some dust stuff we're looking at. So we're again going to leverage off of what we did before and find some other creative ways to keep working together and keep answering these questions. And I think it's really powerful when we both can contribute to these, and then it has a science function, but then it also has kind of a feed-forward ops function for us on answering questions that will really help us get better prepared for the future.
And so that's new developments in our Mars program line. The reason I stress that is that it's I think, a leading indicator of where we hope the agency is going with tighter cooperation on exploration, that we're exploring, we're doing science, and that will apply at any of our potential destinations, whether it be the moon or a near-Earth asteroid.
And another example is LADEE, which is getting ready to go launch here, right? The lunar dust experiment. It carries with it the next generation of laser comm, kind of for the ops side of things. But then, if you fast forward that pretty quickly, this photon counting technique is going to potentially allow us to get really high data rates from distances as far as the moon or even out into Mars kind of distance. So it's
going to need that too.
And so I think it's a pretty interesting, again, synergy of where we were able to find a few extra pounds of mass performance on LADEE and got this instrument added, and during the confirmation phase we'll actually get a chance to check out the LADEE and get, the laser comm, and get a chance to see some of the data come from the vicinity of the moon. And that's pretty intriguing when we get that data here in September. So again, I think you're going to see more of that stuff between John and I as we keep moving forward.
Yep. So LADEE, September 6th.
Yes, and we're excited about that, very much so. We have a few questions in the chat room now. The first one I'm going to take is from Barb Cohen. She says, it's nice that the Mars program is doing well, but the lunar program is being zoned out, or zeroed out. Can you talk about the lunar program and its place for both, let's see, I lost my track, for both human and science exploration?
Well, we're sending Laddie out September 6th. That's part of the program. We have the Lunar Reconnaissance Orbiter that's still doing its important work. And in fact, we're still mining data from the Grail mission, which has turned out to be enormously interesting. The question is, okay, well, what's up for the future?
We're doing some things on station, if you're aware of, where we are doing the stuff at the Ames lunar yard, right? We don't necessarily say it's all lunar, but we're looking at actually deploying some Mylar, right, which could actually make some kind of radio astronomy telescope, and that's being commanded from the space station using delay tolerant network commanding protocols which we've developed. So it's kind of interesting to see us start looking at potentially how we can use operations in orbit around various bodies, the moon potentially, Mars, etc., and then do some low latency telerobotic commanding. So we're getting a chance to experiment and see some of those areas also grow. So I think that's another area that shows that the focus may not be publicly on the moon, but there's still clearly some interesting things we can do in the lunar area.
Okay, I'm just going to do reds. So one of our questions, our next question actually scrolled up, so I'm going to read the latest one here, and we'll get back to the first one. This is from Brad Jolliffe at WashU, and one of the aspects of the Lunar Science Forum conference presentations has been to demonstrate that there's a lot of great work being done in lunar science, especially results that continue to come in from LRO mission and recent past mission results. And Laddie is coming up. Will there continue to be strong support for these missions because they're providing great science now and information that will be needed when we go back into deep space with humans, hopefully in part to the moon?
Well, I think the first thing to consider as we talk about the first deep space missions, and I'll hand it back over to Gerst, but the first deep space missions, which are to rendezvous and interact with an asteroid, are in fact lunar missions. They're going to be in a lunar orbit, and so there may be other opportunities to do lunar research, or in the buildup of deep space missions, maybe to do some lunar robotics similar to what the Colorado node had developed, and that's now being extended out to Ames.
Yeah, again, I think, when we talk about the asteroid being in the distant retrograde orbit around the moon, the robotic spacecraft that we potentially use to do that spacecraft could be detached from the asteroid. We're still in the middle of the kind of the mission formalization review, which will be completed here in a couple weeks. And then maybe we could actually even repurpose that robotic spacecraft if there's enough electric propulsion there to actually go do some other things in the vicinity of the moon, to come out of this distant retrograde orbit, maybe go down even to low lunar orbit with it, maybe even go to Lagrangian points, etc. So some of these things that we're doing in this asteroid mission actually has some applications. It's in the vicinity of the moon, and then how we can maneuver around in cislunar space with an electric spacecraft of the size that we would return this asteroid with could be some pretty intriguing things that open up some new possibilities that I don't think we've really fully fleshed out that we're going to do during this formulation activity that's coming up.
Okay, thank you. And we have a question from Bill Botke at SWRI. He says, what can you say about the NASA planetary budget given the rejection of NASA's off plan by Congress?
Well, I wouldn't say Congress has rejected the ops plan. The ops plan, by its very nature, is something that allows us to take the appropriated budget and apply second order or third order corrections to reflect the actual timing of when we get the appropriation. And so that's something that is worked between our chief financial officer, the Office of Management and Budget, and the Congress. And as far as I know, it's still in work. So that's not something that, it's, I'm trying to think of some, home analogy, but I can't think of one offhand because nobody runs their home this way. But anyway, it's
Check is in the mail.
It's really at the margins, but I think there's still, it's still clear that there's a a divide between what the administration wants to fund Planetary at and what the Congress wants to fund Planetary at, and we're part of the administration, and so I think the more interesting question, and hopefully that's actually been answered, I just haven't seen the results, is we have an administration proposal for the fiscal year 14 budget, which in the event of a bill would start on October 1st, and the Congress gets to weigh in on that, and the House has weighed in on that, and they've supported a higher Planetary budget. We're awaiting word on the Senate, and then they go into conference and agree upon one. I think the more difficult and interesting question for people who vote is, will the Congress come up with a federal budget, and will they come up with one that NASA will then receive its fraction, that avoids the sequester, because that's the biggest hit of all. So I think that's the more interesting question. To say that it's all really messy right now would be a vast understatement.
I think the biggest challenge is we really need, hopefully we get some congressional agreement that can get rid of sequester, because if sequester continues, it's just a mess for everyone. It's macro cuts at the high level. In 14, they're actually directed cuts in particular line items depending upon exactly how it gets implemented, and it's not even our congressional oversight committees that get to set that. It gets set more on the fiscal side. So that's a mess for us if that comes through, and so we just got to hope that calmer heads prevail overall between Congress and they figure out a way to solve sequester. And then the other stuff we're talking about is important, but in the big scheme of things, it's not as important as solving the overall bigger problem that sits in front of us.
Thanks very much. Boy, is that true. We all have our fingers crossed. The next question is also from Bill Botke. Will there be an AO associated with the Grand Challenge RFI white papers that are due today? Let's see.
Let's go through the whole process.
Yeah, I think so the Grand Challenge is relatively, this particular Grand Challenge, the Defend the Planet Grand Challenge is relatively new, and I think the point of the RFIs is to determine, based on the public interest, what our path forward will be. And so it's possible it could result in an AO, but we don't know the answer to that yet. We have to first see what the response is.
Okay, we have a question about the private sector. Given the fiscal restraints faced by NASA for the lunar program, what can NASA do to work with the private sector companies that are planning to focus on the moon? Transportation, ISRU, human return to the surface. How might NASA leverage its limited resources with those groups?
Yeah, I can't specifically talk about those, but we just recently put out an RFI for Lunar Lander kind of activities that was done under Advanced Exploration Systems. And the purpose there was to see, we've been doing some things in-house, I think you're well aware of, is the Morpheus and Mighty Eagle from the two centers have been doing some lander activities that have application clearly to the moon. And then we sent out this RFI to industry to say, hey, we've been doing a lot of this work in-house. Is there anything that we've been doing, we NASA have been doing, that would be beneficial to you, and what might you give us in return to go support some of that? We've also been working with the Canadians on some drill activity. We've been doing some stuff with a little rover at the Kennedy Space Center, again with in-house civil servants. So I think at this point it's probably also too early to say exactly how we're going to interface with the private sector and with industry, but we actually asked them, was there any interest from their standpoint on ways they thought that we could help them under a no cost or no transfer of funds basis. I think that RFI results are due in a couple of weeks later than this current one. It's probably another 2 or 3 weeks. And when we get those back, we'll then start seeing if there's something there that we could do that keeps us kind of moving forward in a general sense. But it's interesting, almost as we've asked your institute to be a little broader than just focused on the moon, we're kind of doing the same thing with our development with at least within HEO. You know, I'm doing these landers and these other things. The first application could be the moon, but they also have applications to other bodies, and so we try to treat them a little more generically than we would have in the past. In the past, we might have just picked a particular destination, said this is what it's doing, but we're looking at, like hazard all-terrain, or the ALHAT stuff, right? The landing hazard tracking stuff to autonomously land around boulders and boulder fields. That clearly has applications to Mars as well as to the moon. So we're doing these things under the guise that, yeah, they may be used first on the moon or they may fit in that region, but they also have application in other areas. So much like we've asked your forum and your institute to broaden your focus, we'll be doing the same thing. So when you see us dropping RFIs, they have a broader look than just a particular destination.
Thank you very much. Our next question is from Clive Neal. What progress has been made with developing ISRU on the lunar surface? Are there still plans to send the Resolve package to the lunar surface in order to have a technical demonstration that resources can be mined and processed on the lunar surface? This potentially opens up deep space for human spaceflight.
And that's what I just described. The RFI that we just sent out is looking at potential ways for very low cost we could potentially get some kind of ISRU device to the moon with the drill capability potentially provided by the Canadians or some other folks. And I think it's also interesting you see the same discussion in the Mars activity, right? We're looking at the Mars package we might fly on the next rover is again to be some kind of ISRU package there to look at taking oxygen out of the Martian atmosphere and trying to compress that to generate some things. So I think what you're seeing is again common developments and common technology themes that have applications in a multitude of environments. And then this is where your institute is really set up well is, okay, if we build this common technology, what are the differences between these environments that then fold back into the technology? In other words, clearly some things that we don't have to worry about on the moon, you have to worry about on Mars, and likewise, if you can take that broader look and look at it as a continuum, can I build a device that can work in one environment, then not have to be totally 100% redesigned to go work in a different environment? So you may be set up with your interdisciplinary teams to go look at some of these things and how much of a difference is there from a technology standpoint needed in one environment or a different environment.
Okay, well, thank you very much. We do have a couple more questions for you, but I know that John has to leave promptly, right now, I think, to be downstairs for the award ceremony. So I was just wondering if you could close perhaps on a note about the future of the Institute, virtual institutes in general, or Survey in particular, whatever you would care to comment on. I think you've done a great job of bringing these two communities together, exploration and science. And we know that you're strongly behind it, but I'd like for the community to hear what you've told us privately. So if you would do that, I'd appreciate that.
Again, I don't understand. Boy, this is tough. What did I tell you? I don't think I've told you anything privately I haven't said publicly today. So if you think there's some secret, there is no big secret. You're going to find out that I don't really hold many secrets. But I did not mean to imply that. Sorry, I know. I'm just teasing
you've always been very supportive.
I know. So you're virtually a little ways away, so you won't throw large objects at me or hit me, right? So we're okay.
It's coming out on the printer now.
And somebody said something anyway, but again, I think you guys have done a great job of doing the challenge that we talked about. I think, again, the virtual aspect is, I think, difficult and is not easy. You've done an extremely good job with that. We're going to use you, I believe, in this activity with the asteroid in the September timeframe. We're going to use you as part of the way to pull off some of this stuff virtually. So again, the experience of bringing together this diverse group has been tremendously productive. So again, we look for good results. We'll continue to try to give you challenges as you move forward.
I'll just add that I really enjoyed watching the Virtual Institute grow and also change over time as the circumstances change. This is a very challenging budget time, and I appreciate everybody's patience. Not that any of us can do anything about it. as we all try to weather these difficult times and still keep, the dream of exploration alive. As I think almost all of you who know me and many folks out there do, I think that science is exploration, exploration is science, and that, we're more powerful when we move forward. One of the questions that often comes up is, well, who is really the customer, the constituency for human spaceflight? Is it just the vague, U.S. public? And the answer is no. It's actually more. It's yes, but it's also much more. And it's people who, and there are some folks like Clive Neal that I've talked to for many years, who really wants to see scientists on the moon, who want to see scientists out in space, want to see scientists on Mars, doing the kind of work that we've all dreamed about. And I think Survey is a really good step in that direction.
Wonderful.
Thank you.
Thank you so much. And thank you so much for taking time to be with us today. And we hope that you have a chance to see some of these wonderful talks. The science has just been hard-hitting and absolutely wonderful. And it really shows how exploration science work together hand in hand.
Yeah, really appreciate it. Thank you.
Thank you so much.